Hello, in this video we will look at how to use PE-BPMN stereotypes, how they can be added to a model, what's the logic behind the menus, and what we can do when we have added them. And for example, we consider a case of adding a new contact to your mobile phone. So we start with some sort of phone number that is turned into contact data, and then we know that we have identified that we want to apply some sort of data protection on this. So we apply some sort of protection, and then we store it in our address book that resides in a cloud. When we send the contact data to a cloud, then the cloud updates the address book and stays with it. Then at some point we will turn to the address book with some name to ask for the contact data. This is sent to the cloud. The cloud searches for this particular contact in the protected data, and it finds the contact, it sends the protected data back, and in this case to use the contact data we want to remove the data protection that we have. So it's another task to figure out which steps in the process actually require some sort of privacy enhancing technology, but for this example assume that we have identified that these are the things that we want to protect. And right now we are looking at this model in Pleak's PE-BPMN and Lixman editor, and concretely in the PE-BPMN view. So PE-BPMN, or Privacy Enhanced Business Process Model and Notation, is an extension to BPMN that allows us to exactly mark which tasks or other objects on the model have something to do with privacy enhancing technologies, so that we can then analyze the data visibility in the model based on these technologies. And in order to use this, we have to click on the model element that has something to do with privacy enhancing technologies, for example this protect contact data task. And if we click on it, then we can see a stereotype menu appearing. So stereotypes are the things that we use to add privacy enhancing technologies information. In this case, well, the task is to protect data, and the first task for adding the stereotype is to choose which kind of goal our privacy technology has. And in this case, we want to do data protection, so we choose data protection. Concretely, we want to protect the confidentiality. So we will look at which technologies Pleak supports for protecting the confidentiality of the data, and we can see a list of tasks appearing in this menu. So we have different technologies like public key encryption, symmetric key encryption, attribute-based encryption, different things for secret sharing, SGX, and so on. In this case, assume we are not yet decided on which technology concretely to use, but we know that we want to apply some sort of protection, so we'll choose the protect confidentiality stereotype in here. Once you make a choice in this menu, you can see the stereotype specific panel appearing in the right hand side, so you can verify the information. So we added protect confidentiality. The input data of this task is the contact data. The output data of this task is called the encrypted contact data, and these are also highlighted in here. So once we add the stereotype, the idea is that in this task the contact data is turned into encrypted contact data, well, in this case applying the generic protect confidentiality stereotype. And if that is what we wanted to do, then we click save. So now we can see that in here we have something protected that is sent over the network. Encrypted contact data is received here, and now we want to update the address book. So let's say updating means that we want to check if we already have this contact data, maybe merge some data and so on. So we have to take this protected data and process it somehow. So in this case we want to do some sort of privacy preserving data processing. So when we click on the task, and now we choose the data processing submenu, and well, we want to choose something that's preserving privacy because, well, the object that we got as an input is already protected. And since we are in a generic level, then we're leaving it also in the generic level in here, choosing PET computation. And again, we see a menu appearing here. So we know that this input is encrypted or protected with protect confidentiality that we already added. So this input is private, and we also say that this task is such that the output also remains private. So we fix these details, and we can click save. And now we continue with the next, let's say, part of the process when the user sends some sort of a name, and we want to check if or what kind of contact data we have for that party. So again, we have some sort of a task that has to process protected data. So we again choose the privacy preserving computation and the pet computation. But in this case, a friend's name was sent to us in public, so we mark it here as public. Encrypted address book is private data, and let's say, well, we want to keep this output also as private because the cloud does not really need this information. And again, we click save. Now this contact data is sent back to the party, and we know that as a last task we actually only want to remove the protection. So now we have to select this task. We're still in the data protection kind of type category and still in the confidentiality protection technologies because we want to remove this open confidentiality that we had added before. However, now we can have to look at the second part of this menu. So we have tasks that deal with data confidentiality protection in here, and then we have a list of things that actually do opening. So if we scroll to the end on here, then we see the reverse of protect confidentiality or open confidentiality task. We click on it, and similarly as before, we can see and check the information. So the idea of this is that the input data is the encrypted data of our friend's contact, and then we open it to receive the actual contact. So again, we can save the stereotype, and also once we have done all the changes, we can also say change full of the diagram. So right now you can see that there is the stereotype names have appeared under the tasks that we have identified. Also, if you click on these tasks, then you can see which data objects are connected to them. So we have added this information. Next question is, what is it all useful for? So we want to run a PE-BPMN analysis. Every time you run it, at first it checks if the stereotypes are syntactically correctly added to the model. In this case, it's the case, so we get the past validation. So let's look at the simple disclosure analysis, for example. So in here, we can see the simple disclosure report for this model. So first of all, in the rows, we have the different parties, so cloud and mobile that we have in here. In the columns, we have all the data objects that appear in this model. And first of all, we can notice that these O's in here denote that the phone number that we started the process with and the friend's name that we queried are something that are originally owned by a mobile phone before the start of this project. So these are the input objects to this project or this process. And then we can see this V and H marker standing for visible and hidden to show which data is protected or not. So for example, we can see in the first column here, we have joined the columns for contact data and encrypted contact data because they have the same content, just different status whether or not they were protected or not. So we can see that on the cloud side, they only see the protected or encrypted data. So we have H for hidden, as this content is hidden from the cloud. On the mobile side, we have V in here, saying that they of course can see the contact data because they created this data object. And we can see that on the cloud side, it doesn't see anything about the contact data or address book. However, of course, the friend's name that we sent to this party, it can also see. However, then, other than the parties that are explicit in our process, we also have another line called shared over, which summarizes what can be seen on the network. And in this case, well, we have in the message flow with object that is hidden. In this case, we sent encrypted data. Similarly, in here, there is a message flow that contains this object, but it's sent over, but the object itself is protected with protect confidentiality or yeah. However, in this case, we see that there is a message flow where the data is also visible. So not only is the friend's name seen by the cloud, but in this particular case, we can say that it's seen by anyone who is observing the network communication. And we can solve this by, well, first of all, identifying that this is the message flow where the friend's name is sent to the cloud. And then similarly to how we clicked on the task, we can also click on a message flow to add a stereotype here. So we have this secure channel stereotype that, for example, can be used to denote that it's a TLS communication or whatever other secure networking communication. And similarly as before, we save this model. Now, if we run the same analysis, we can see that an S appeared here saying that now this data is sent over a secure channel. So in terms of leakage analysis, we assume that it does not leak to any parties. So far we have seen that clicking on a task opens a menu that is specific to task stereotypes, and we have grouped them kind of based on the goal of the technology. And then similarly, if you click on a message flow, you can have a message flow with secure networking stereotypes. In addition, you actually, for some technologies, can also use stereotypes on the data objects. We use them in Pleak to mark different key pairs for public key encryption. And you possibly can also see that there is some sort of a pattern forming from these names. For example, we have PK public and PK private in here. And if you look at data protection and confidentiality protection, we can also see something called PK encrypt, or on the opening side, PK decrypt. So in fact, we have designed it so that for different privacy enhancing technologies, there is usually many stereotypes that make up different parts of this technology. For example, we have encryption task with PK encryption, for example. Then we can have decryption tasks with PK decryption stereotype. And these are specifications then of concrete technology that is used in the same goal as, for example, this protect confidentiality and open confidentiality are used. So on one hand, you can, or you have to look at what is the goal of these tasks, whether it's, for example, protecting data or doing some data processing. Then you also have to think of the concrete technology and use the correct stereotypes for that technology. And you can find more information about which technologies we have addressed how in Pleak wiki page. We have this page that summarizes the different technologies and what are their stereotypes. So for example, secret key and public key encryption, secure multi-party computation, and for some of them also example models are provided. In addition, there is also a more detailed page for all of the stereotypes that have been implemented, and you can get some of the overview of the language design. So let's now look at the same process, but assume that we have decided that we want to use public key encryption instead of this generic stereotypes. So we have still the same tasks, so we click protect contact data and choose data protection, confidentiality protection, and now we choose public key encryption. And well, we can see a similar menu appearing. However, we have to now fix the roles of which is the input and which is the key. Well, we only have one input, so let's see what happens if we try to just save it like that. And in this case, we get an error that this task does not meet all the requirements of this stereotype. So all the stereotypes have some sort of restrictions on where they can be applied or how they can be applied, and some of these are structural so that we can identify them when we're actually trying to add this data. And in that particular case, you should also notice that since it expects to have input data and the key, then probably the key should also be a data object on the model. So let's fix this. In order to do that, you have to add the data object. So for that, you have to change to the modeler view. So we will add public key data object, and it's also the input to the encryption. So let's save the diagram and change the editor back to PE-BPMN editor, and let's try to add this encryption stereotype again. So now we have, input data is the contact data and the key is of course the public key. So we have the two inputs and we want to save them. However, we get another error saying that the key object must be of type PK-public. Specifying that it means that we have to use the stereotype. So it's our first chance to use actually the stereotype for the data. So if you click on the data object, we can see that there is a chance to mark it as PK-public or PK-private. In this case, it's the public key, so we choose the first stereotype. And since in public key encryption we have a key pair consisting of public and private keys, then we have to add in Pleak we have to give it a name. So let's just call it key pair because we only have one key in this model. So we add this new identifier for the key pair, and we save this stereotype. And now let's try to add encryption stereotype again. So we have to choose that the key is public key data object. And now we have successfully saved the stereotype. So we have this PK-public stereotype appearing for this data and public key encryption stereotype appearing for this task. So already before I added this PK computation tasks here instead of the PET computations that we used before, but these are used similarly, but just these are the one computation tasks that are matching with the PK encryption or public key encryption technology that we are using in this process. So let's see what happens if you're trying to run the analysis, and we can see another error. If we click on it, then we can also see which model element this error applies to. So there are some errors that we can't check necessarily when adding something, because this error says that for this PK-public stereotype we also should have a corresponding private key with the PK-private stereotype on the model. So we can't check it. We can't check it during adding the stereotypes, but before analysis, Pleak identifies that something is missing, and indeed we have actually not done the final step yet, where we do the decryption. So this key is entirely missing. So we have to go through the same steps again, that we switch to the modeler view. Then we add the private key data object that is input to the decryption task. Then we change the editor back, and now we have to choose that this is actually the private key, and we can already see that we have a collection of all the possible key pair identifications on this model. In this case, we wanted to pair with the data object or the key in the key pair name. We can also see that it's highlighted on the model. So if this is the pair that this public key belongs to, then we should save this diagram And we can see that this error also has vanished. And well, of course, we should finalize this with adding also the corresponding decryption task. So public key decryption. We know that we have a ciphertext, that's the encrypted data. We have a key, that is the private key. We have to fix the input parameters of the stereotype. And now we have fully replaced the protect PET computation and open stereotypes with PK encryption, public key based homomorphic computations, and public key decryption. And if we want to, then we can again look at the stereotypes.